Welcome everyone to this next Global Trends video series where we discuss some of the key areas where the material sciences and in particular nanotechnology are having a big impact in the development and innovation of different industry sectors. Now this is the third video in our series and it follows on from the other two on human health and future cities, which have been published on the Cerion Nano website. So today we're going to discuss another area which is a major global focus and perhaps one of the more critical areas of modern day society, and that is energy. Introduction. So for those who don't know me, my name is Critchley. I'm a subject matter expert in chemistry and nanotechnology, and I'm joined here once again by Landon Mertz, the CEO of Cerion Nanomaterials. Hi, Landon.
Hey there, Liam. Great to be here.
So if you don't mind, before we get onto energy and the topic of the video, can you tell everyone a bit about Cerion?
Yeah, of course. So we're a 15-year-old company that today is one of the largest in the United States for designing, scaling, and manufacturing nanomaterials. Specifically, we focus on metal oxide, and ceramic nanoparticles. One of the things that makes us unique is that we don't develop products to solve industrial challenges. Rather, what we do is we support product developers and their companies who are looking to leverage nanomaterials from cradle to grave, usually starting at applied research in the lab and then ultimately carrying them through commercialization and manufacturing.
And what do you see personally for material science like moving forward from here on?
Yeah, it's a very relevant question. As we look out over the next, say, 50 years, we're going to be coming under population pressures that far exceed what we see today. And those pressures are going to manifest themselves into challenges across key areas. You could think health, water, air, the food supply. And when you look across history, you're going to find that every advancement of society is built in one way, shape, or form on critical innovations that happened first in materials. For example, you look at concrete, which was created during Roman times, steel ushering in the industrial age, or silica bringing us the computing age. And so if there's anything that I'm certain of, it's that material science is definitely going to play a central role in addressing these future challenges caused by population pressures over the coming decades.
Agreed. And from my experience, I also seen as well with nanomaterials specifically that they're starting to penetrate quite a number of areas, but we don't always hear about it. So here as I previously mentioned, we're going to talk about nanomaterials in the energy sector. So when we hear about nanotechnology and energy, the first reaction that many have is to gravitate towards batteries. And while we both know that batteries are a key commercial area for different nanomaterials today, the role of nanotechnology in the energy sector is, I'd say, much further reaching than batteries, and extends to not only a range of other energy storage devices, but also different areas like energy production, fuel and emission improvements, and energy distribution, to name a few of the key areas. So for anyone that's in the other videos, this one's going to be slightly different, because there's so much in the energy sector, we're not going to deep dive quite so much. We're going to try and cover the broader spectrum of nanomaterials energy, let's say, and look at a number of the key macros in a broader sense and see where nanotechnology is having a key impact. So if we move on to the first of those areas, Landon, we'll talk about energy sources. So what impact has nanomaterials had on our ability to create and harness energy from different sources? And is the integration of nanomaterials helping to improve the carbon footprint of the energy sector? And what can we envisage going forward for the future of nanomaterials in this area?
Yeah, so to your second question first, energy use is ubiquitous. It's integrated into almost every single process that we have industrially today. So anything that you do to increase your efficiency, your productivity, ultimately is going to have an impact on your carbon footprint. So think of it almost as each unit of work you're producing more with less. So in this regard, nanomaterials are already having an impact today across a wide variety of sectors in improving productivity and doing more with less. Now, in terms of applications, I know the world isn't particularly excited to talk about oil and gas because of its impact on climate change. But if we're being honest with ourselves, it's here to stay for some time. And during that time, nanomaterials really have brought about some great innovations. If you look at the area of oil and gas discovery, What we're seeing right now is the beginning uses of iron oxide nanoparticles where they inject it into the well so that they can take images of the reservoir. Think of almost like an MRI. In the area of drilling, there's new innovations which are being incorporated now into drilling fluids where you take nickel nanoparticles to reduce the friction drag between the borehole and the drill pipe. And in extraction, which I find personally fascinating, we're seeing some new changes in proppants. So proppants are usually sand that's pushed into the well under high pressure during hydraulic fracturing. And the whole idea is you use the sand to hold open the induced fractures in the rock, and it allows more oil and gas to escape the fracture. And nanoparticles have been shown and are being commercially used to penetrate now into what are called so-called microfractures. And so this yet again increases the amount of oil that you can recover commercially.
No, thank you, Landon. Like I said, we're gonna jump topics here. So if we move on to our second area, which is energy conversion. So in this area, where are we seeing nanomaterials being used, and what would you say are some of the main benefits and future prospects for nanomaterials in the energy conversion space?
Yeah, this is no doubt a broad topic area. There are a lot of examples out there. The most practical, I think, and ubiquitous application today would be turbines and power plants. So most turbine blades are subjected to really high heat of over 1300 degrees C, which weakens the blade over time. And the primary strategy today is to reduce the impacts of heat, which cause stress fractures. And you do this using thermal barrier coatings, which are usually made of ceramics. Nano ceramics represent really a new novel area for improvements, and any a higher operating temperature that you can achieve ultimately gives you better efficiency. And you would do this with nano ceramics by having a tighter packing density of the coating, a more uniform coating capability, which reduces oscillation and stress in the overall system. And then, of course, there are solar panels. So these are used very widely. Nanomaterials are used very widely in these applications today. So you have gold and silver nanoparticles that are being used to improve the performance of the solar cell, basically by tuning light absorption and reflection. You also have multiple types of nanomaterials that are used in the conductive traces of the solar cells itself. And then in the future, I think what we're going to see is that dye-sensitized solar cells are going to come to the market. And here, titanium dioxide plays a really critical role. Basically, they act as an electron carrier from the dye material to the electrode.
Thank you, Landon. Now, so if we move on to energy distribution. Now, distributed energy from, different sources, you mentioned a few there, has always had, there's always been some challenges to overcome over the years. What has nanomaterials brought to energy distribution so far, and what impact could we see it having in the future?
Yeah, when I think of energy distribution, obviously I immediately think of power transmission. And in this area, I truthfully am not clear that there has been much innovation using nanomaterials that's reached the market. I am aware, however, that there's new work being done with high voltage transmission lines at the applied research scale. And kind of the problem with these lines is they're very susceptible to ice accumulation, which results in damage. The current systems out there use a fluorescein resin system to address the problem, but the fluorescein resin itself is susceptible to damage due to temperature changes. And so I know that there is work going on right now using thermally conductive nanoparticles like a boron nitride. And you add that into the fluorescein resin, and it appears that it meaningfully improves the performance of the overall system.
Thank you. And now if we move on to our fourth area, and perhaps one of the most talked about energy storage devices. So as I previously mentioned, we touched on that batteries get a lot of attention in the energy storage space. But what other developments are out there that you're seeing in the energy storage space that where nanomaterials are being used?
Yeah, to my knowledge, nanomaterials haven't yet made it into large-scale commercial battery systems. These technology platforms take decades to develop. And right now, as you know, Liam, the dominant solution is lithium-based technology. In the lithium category, there has been quite a bit of scientific exploration around improving conductivity and storage capacity of electrolytes. And I've seen work done in this area using aluminum, silicon, and zirconia nanoparticles. And then, grid scale storage is a really interesting area to me personally. One of the challenges of lithium batteries is their high cost, which I think just about everybody knows. And this really limits its use in commercial utility scale power storage. So one of the next frontiers for grid scale storage are these types of batteries called redox flow batteries. And two of the primary challenges of the batteries themselves are very low charge and discharge rates, and the actual stability of the chemistry itself that makes the whole system work. And there's been work that's been done that shows that electrons made of carbon that are then decorated with tin oxide nanoparticles will improve both of these performance characteristics. There was one paper I was reading that showed the discharge rate improved by, I think it was almost 25%, but the stability of the chemistry improved by a factor of almost 3 times compared to the conventional redox flow electrodes. It's certainly going to be some time before any of these systems get to the market, but certainly they're going to have impacts within storage.
Oh, thank you, Landon, for the insights. Now, if we move on to our final area now, final number 5, that's energy usage. So for this final area, what would you say are, some of the key areas within energy usage where nanomaterials are getting involved, or people are getting involved in nanomaterials, shall I say?
Yeah, this area is always interesting to me because there are so many different areas where you can have big and meaningful impacts, and we could probably dedicate an entire episode to just discussing this particular topic. But first, and probably the most high impact area for the future will be lightweighting. So you can think automotive here, but really it applies to almost any mode of transportation. And a big area of focus today is in creating kind of new classes of materials. For example, being able to use something like aluminum without having to sacrifice performance that you would get with steel. And one way to do this is using materials that are ultimately made of nanostructured grains. And what you're doing here is you're taking a material, say aluminum, and you're adding in other materials to influence the behavior of the aluminum at the grain boundary of the sintered object. And this is an area of immense study. Cerion ourselves have invested in not only lab scale, prototype scale, but manufacturing scale of these types of materials. And we're quite excited about it. And then, of course, you can always include composites that are reinforced with nanomaterials. There's a ton of commercial innovation that's happening here right now. Another big impact area that I would probably focus on would be thermochromic and electrochromic glass. So this is where you have invisible coatings of nanoparticles on the glass itself. And either heat or electricity can induce changes in that coating, in essence, really modifying its optical properties. And in doing this, you can tailor the amount of infrared heat that comes into a building, let's say during the winter, or how much you reject, for example, during the summer. And you can reduce your heating and cooling costs by about 20 to 30%. And this is commercially available on the market today. Now, if you consider that 35% of a building's energy consumption is heating and cooling, this is a pretty significant benefit.
Oh, thank you, Landon. And yeah, echoing sentiments on the video, I think the scope across energy could have you could do a video on many of these different topics and deeper dives because we all just scratched the surface. But that is all that we have time for today. So for anyone who's been watching, as been discussed, you can probably tell that there's a lot going on in the energy sector where nanomaterials are concerned, and we have only been able to scratch the surface here. Otherwise, I think we could be here for hours, to be honest. But we hope that the areas that I've discussed not going to only provide some insights to where material science is having an impact in our everyday lives, but it's also showcasing how nanomaterials are already playing a major role in the energy sector and how future developments could in nanomaterials and energy, is going to provide the pathway in the future. So I'd like to thank you, Landon, for your insights today.
Yep. Thanks, Liam. It was great to be here with you.
Thank you. And so everyone else, will see you next time. Thank you. Goodbye.
Thanks. Bye.